Lieutenant Commander Takeshi Yamamoto felt the familiar bite of centripetal force as he rolled his Kawasaki Ki-61 Hien through a knife-edge turn at 18,000 feet above the Mariana Islands. The date was August 3, 1944, and Yamamoto commanded the 15th Fighter Wing's most elite interceptor squadron, veterans who had survived the grueling campaigns from Guadalcanal to Rabaul through sheer skill and an intimate understanding of aerial combat dynamics. His pilots were masters of energy management, capable of executing maneuvers that pushed both aircraft and human physiology to absolute limits. But what Yamamoto witnessed at 11:32 hours that morning would shatter every assumption he held about the boundaries of human performance in aerial combat. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Through the crystalline Pacific air, 6 Grumman F-6F Hellcat fighters approached in a loose combat spread, their navy blue paint schemes stark against the tropical sky. These were no ordinary American pilots. They belonged to VF-31, an elite carrier squadron whose reputation had grown legendary among both friend and foe throughout the Central Pacific campaign. What made this encounter different from the dozens of dogfights Yamamoto had survived wasn't the aircraft themselves, but something invisible that would prove far more revolutionary than any technological advancement in engines, guns, or armor. The first indication that something was fundamentally different came when Lieutenant Commander Jake Morrison, leading the American formation, initiated a diving attack at a rate that should have been physiologically impossible. Yamamoto watched in amazement as the Hellcats plunged earthward at angles exceeding 70 degrees while maintaining perfect formation discipline. Standard fighter tactics required gradual altitude changes during combat maneuvers because excessive G-forces would cause pilot blackouts, loss of consciousness, and inevitable crashes. Every experienced aviator understood the iron law of aerial combat. Human physiology, not aircraft capability, determined the limits of fighter performance. Yamamoto signaled his squadron to intercept, beginning a climbing turn designed to position his Ki-61s for a classic overhead attack. The maneuver required precise timing and energy management, trading altitude for speed while maintaining enough control authority for the final engagement. As his formation approached the optimal attack position, the American fighters suddenly executed a coordinated pull-up that defied everything Yamamoto knew about human endurance under extreme acceleration. The Hellcats transitioned from their steep dive into climbing turns that generated G-forces exceeding 8.5 gravities, sustained for periods that should have rendered any pilot unconscious within seconds. Yamamoto felt his own vision beginning to gray as he attempted to match the American maneuver, the familiar tunnel vision that preceded complete blackout, warning him that he had reached his physiological limits. Yet the American pilots continued their impossible climb, not only maintaining consciousness, but executing precise tactical movements that required full cognitive function and motor control. Captain Hiroshi Matsuda, Yamamoto's most experienced wingman, radioed his disbelief as he watched the American formation complete maneuvers that violated every principle of human performance he had learned through 5 years of intensive aerial combat. Matsuda had survived encounters with American P-38 Lightnings, P-47 Thunderbolts, and F-4U Corsairs, learning to exploit the physiological limitations that affected all fighter pilots equally. The fundamental equation of aerial combat had always been simple. Aircraft performance was ultimately constrained by human tolerance for acceleration forces. The revelation that American pilots could somehow exceed these limitations represented a paradigm shift that challenged the very foundation of Japanese fighter tactics. Matsuda's own attempt to match the American climb rate resulted in complete loss of consciousness, his Ki-61 entering an uncontrolled dive that nearly ended his military career. Only years of training and recovery procedures saved him from certain death, but the psychological impact was immediate and profound. If American pilots could operate beyond normal human physiological constraints, every tactical doctrine developed by Japanese Fighter Command had become obsolete overnight. The secret that American pilots possessed was invisible, revolutionary, and would change aerial warfare forever. Inside the cockpit of each Hellcat, the pilots wore what appeared to be ordinary flight suits, but incorporated within the fabric was technology that represented years of intensive research into the effects of acceleration on human physiology. The anti-G suit, developed through collaboration between medical researchers, aerospace engineers, and combat pilots, was designed to counteract the blood pooling that caused unconsciousness during high-G maneuvers. When acceleration forces pulled blood away from the brain toward the lower extremities, pilots experienced a progressive loss of vision, cognitive function, and eventually consciousness. The phenomenon had been understood since the earliest days of aerobatic flying, but no practical solution had been developed until American researchers began systematic investigation of physiological responses to acceleration stress. The breakthrough came through understanding that external pressure applied to the legs and lower torso could counteract blood pooling, maintaining cerebral circulation during extreme maneuvers. The anti-G suit incorporated inflatable bladders connected to the aircraft's pneumatic system, automatically pressurizing in response to acceleration forces detected by sensitive instruments. When the pilot initiated a high-G maneuver, the suit would inflate within milliseconds, applying graduated pressure that prevented blood from pooling in the lower body. The system was completely automatic, requiring no conscious pilot input, and could sustain protection for extended period during prolonged high-G flight. Lieutenant Commander Morrison had been among the first operational pilots to receive anti-G suit training at the Naval Air Test Center in Maryland, where researchers had developed comprehensive protocols for maximizing the system's effectiveness. The training revealed that pilots equipped with properly functioning anti-G suits could sustain forces exceeding 9 gravities for periods that would have been fatal without protection. More importantly, they maintained full cognitive function and motor control throughout extreme maneuvers, enabling tactical decision-making that was impossible for unprotected pilots. Captain Hiroshi Matsuda, Yamamoto's most experienced wingman, radioed his disbelief as he watched the American formation complete maneuvers that violated every principle of human performance he had learned through 5 years of intensive aerial combat. Matsuda had survived encounters with American P-38 Lightnings, P-47 Thunderbolts, and F-4U Corsairs, learning to exploit the physiological limitations that affected all fighter pilots equally. The fundamental equation of aerial combat had always been simple. Aircraft performance was ultimately constrained by human tolerance for acceleration forces. The revelation that American pilots could somehow exceed these limitations represented a paradigm shift that challenged the very foundation of Japanese fighter tactics. Matsuda's own attempt to match the American climb rate resulted in complete loss of consciousness, his Ki-61 entering an uncontrolled dive that nearly ended his military career. Only years of training and recovery procedures saved him from certain death, but the psychological impact was immediate and profound. If American pilots could operate beyond normal human physiological constraints, every tactical doctrine developed by Japanese Fighter Command had become obsolete overnight. The secret that American pilots possessed was invisible, revolutionary, and would change aerial warfare forever. Inside the cockpit of each Hellcat, the pilots wore what appeared to be ordinary flight suits, but incorporated within the fabric was technology that represented years of intensive research into the effects of acceleration on human physiology. The anti-G suit, developed through collaboration between medical researchers, aerospace engineers, and combat pilots, was designed to counteract the blood pooling that caused unconsciousness during high-G maneuvers.
when acceleration forces pulled blood away from the brain toward the lower extremities. Pilots experienced a progressive loss of vision, cognitive function, and eventually consciousness. The phenomenon had been understood since the earliest days of aerobatic flying, but no practical solution had been developed until American researchers began systematic investigation to acceleration stress. The breakthrough came through understanding that external pressure applied to the legs and lower torso could counteract blood pooling, maintaining cerebral circulation during extreme maneuvers. The anti-G suit incorporated inflatable bladders connected to the aircraft's pneumatic system, automatically pressurizing in response to acceleration forces detected by sensitive instruments. When the pilot initiated a high-G maneuver, the suit would inflate within milliseconds, applying graduated pressure that prevented blood from pooling in the lower body. The system was completely automatic, requiring no conscious pilot input, and could sustain protection for extended periods during prolonged high-G flight. Lieutenant Commander Morrison had been among the first operational pilots to receive and
Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means the discovery that American pilots could operate beyond these limits using some unknown advantage created a crisis of confidence that extended throughout the Imperial Japanese Navy's fighter commands. If the fundamental assumptions about human performance in aerial combat were incorrect, what other advantages might the Americans possess? Flight Petty Officer Kenji Nakamura, one of Japan's most decorated fighter pilots, attempted to analyze the American advantage through careful observation of their flight characteristics. Nakamura had developed an encyclopedic knowledge of American fighter tactics through 3 years of continuous combat, learning to predict enemy maneuvers based on aircraft limitations and pilot behavior patterns. The VF-31 pilots demonstrated capabilities that fell completely outside his accumulated experience, performing sustained high-G maneuvers that should have resulted in pilot incapacitation or death. Nakamura's detailed combat report described American fighters that could maintain crushing G-loads while executing complex tactical maneuvers, suggesting that their pilots retained full consciousness and motor control throughout extreme acceleration stress. The implications were terrifying for Japanese tacticians who understood that aerial combat success depended on exploiting enemy limitations while minimizing exposure to superior capabilities. If American pilots had somehow eliminated physiological constraints from fighter operations, Japanese tactical advantages had been neutralized by an invisible technological breakthrough. The mystery deepened when captured American pilots provided no useful intelligence about their enhanced performance capabilities. Either they had been trained to reveal nothing about their technological advantages, or the system was so integrated into their operations that they considered it routine equipment rather than revolutionary breakthrough technology. Japanese interrogators found no evidence of drugs, special training techniques, or equipment modifications that could explain the observed performance advantages. Commander Sabaru Ishikawa, Chief of Fighter Tactics Development for the Combined Fleet, initiated a comprehensive investigation into American pilot performance anomalies reported throughout the Central Pacific Theater. Ishikawa had access to combat reports from multiple fighter wings, providing a broad database of encounters with American aircraft. The pattern that emerged was consistent and alarming. American pilots were demonstrating sustained high-G performance that exceeded known human physiological limits. The investigation revealed that American performance advantages were not limited to specific aircraft types or elite units. Pilots flying F-6F Hellcats, F-4U Corsairs, and P-38 Lightnings all demonstrated similar capabilities, suggesting systematic rather than isolated technological implementation. More disturbing, the advantage appeared to be increasing over time, with more recent encounters showing even more extreme performance differentials than earlier encounters. Ishikawa's analysis identified specific tactical implications that threatened the effectiveness of Japanese fighter operations. American pilots could sustain offensive maneuvers longer, recover from defensive positions more quickly, and maintain formation discipline during extreme combat stress.
They demonstrated consistent accuracy during high-G shooting opportunities that should have been impossible due to physiological impairment. Most critically, they retained tactical judgment and situational awareness, while Japanese pilots struggled against unconsciousness. The strategic implications extended far beyond individual combat encounters. If American pilots possessed technological advantages that eliminated physiological constraints from aerial combat, they could develop tactical doctrines that were impossible for Japanese forces to counter using conventional methods. The fundamental balance of aerial warfare had shifted in favor of pilots who could operate in flight regimes that remained lethal for their opponents. Medical Officer Lieutenant Akira Tanaka, assigned to analyze pilot performance reports, identified physiological evidence that suggested American pilots were somehow protected against G-induced loss of consciousness. Japanese pilots consistently reported visual symptoms, cognitive impairment, and physical stress during high-G encounters with American fighters, while enemy pilots appeared to maintain full functionality throughout identical maneuvers. The differential suggested that Americans had developed countermeasures against acceleration-induced physiological limitations. Tanaka's medical analysis revealed the critical importance of maintaining cerebral blood flow. When G-forces exceeded approximately 4.5 gravities, blood pooling in the lower body reduced brain circulation to levels that caused progressive loss of consciousness. The process was predictable and universal among human pilots, creating absolute performance limits that no amount of training or willpower could overcome. If American pilots had found methods to prevent or counteract blood pooling, they would possess decisive advantages in any prolonged high-G engagement. The investigation into American physiological advantages became a priority for Japanese intelligence services. But captured equipment and interrogated personnel provided no useful information about the nature of their protection systems. Either the technology was too well concealed for detection through conventional intelligence methods, or it was integrated so thoroughly into American operations that personnel considered it standard equipment rather than classified capability. Wing Commander Toshiro Maki, responsible for training Japan's most elite fighter pilots, attempted to develop countermeasures against American high-G advantages through intensive physiological conditioning programs. Maki understood that if Japanese pilots could extend their G-tolerance through training, they might partially offset American technological advantages. The experimental program incorporated breathing techniques, physical conditioning, and specialized equipment designed to enhance pilot endurance during extreme acceleration. The results were disappointing and dangerous. While specially trained pilots showed marginal improvements in G-tolerance, they remained fundamentally limited by human physiology and could not approach the sustained high-G performance demonstrated by American aviators. Several experimental pilots suffered serious injuries during training accidents, and the program was discontinued when it became clear that no amount of conditioning could bridge the performance gap created by American technological advantages. The failure of physiological countermeasures forced Japanese commanders to acknowledge that Americans possessed technological solutions to problems that Japanese science had not yet solved. The implications extended beyond immediate tactical considerations to broader questions about technological competition in modern warfare. The psychological warfare aspects of American physiological advantages proved as significant as their tactical benefits. Japanese pilots who survived encounters with G-suit-equipped Americans carried stories of impossible maneuvers and superhuman performance that spread throughout fighter units across the Pacific theater. The knowledge that enemy pilots could operate beyond normal human limitations created demoralization that affected pilot performance even before combat engagement. The myth of American pilot invincibility grew with each encounter, fueled by first-hand accounts of fighters that could pull out of dives that should have been fatal, sustain turns that should have caused unconsciousness, and maintain formation discipline during maneuvers that left Japanese pilots struggling against blackout. The psychological impact was particularly severe among veteran pilots who had built their confidence on superior training and experience, only to discover that Americans possessed advantages that training could not overcome. Flight Lieutenant Masao Sato, commanding an elite interceptor squadron based on Guam, documented the progressive deterioration of pilot morale as reports of American physiological superiority spread throughout his unit.
Sato's pilots had previously maintained confidence despite numerical disadvantages, believing that superior tactics and aggressive fighting spirit could overcome American material advantages. The discovery that enemy pilots could operate in flight regimes that remained lethal for Japanese aviators challenged fundamental assumptions about the nature of aerial combat. The impact on tactical doctrine was immediate and comprehensive. Japanese fighter tactics had evolved around exploiting physiological limitations that affected all pilots equally, using energy management and positioning to force opponents into high-G situations that would cause performance degradation. If American pilots were immune to these limitations, traditional Japanese tactical advantages had been neutralized by invisible technological superiority. The broader implications of American anti-G suit technology extended to strategic questions about the future of aerial warfare. If physiological constraints could be eliminated through technological solutions, fighter combat would evolve toward pure aircraft performance rather than pilot endurance. American industrial capacity to produce advanced aircraft would become even more decisive if pilot limitations no longer constrained operational employment of superior machines. The revelation that American pilots possessed protection against G-induced unconsciousness represented more than tactical disadvantage. It demonstrated American technological capabilities in fields that Japanese research programs had not explored, suggesting broader industrial and scientific advantages that could produce additional breakthrough capabilities. The anti-G suit was evidence of systematic American investment in human factors research that Japanese military science had overlooked. For Japanese pilots who had relied on superior training and aggressive tactics to overcome numerical disadvantages, the encounter with G-suit-equipped Americans represented a technological shock that revealed the limits of traditional military virtues against scientific advancement. The invisible advantage that allowed American pilots to operate beyond normal human physiological constraints had changed aerial warfare forever, providing clear evidence that technological superiority could create decisive advantages that skill and courage could not overcome. The investigation into American pilot capabilities took on urgent priority when Admiral Chuichi Nagumo received detailed combat assessments from across the Central Pacific Theater. Squadron commanders from Truk to the Philippines reported identical phenomenon: American fighter pilots executing maneuvers that defied fundamental principles of human physiology while maintaining tactical precision throughout extreme acceleration stress. Nagumo understood immediately that Japan faced technological challenges that extended far beyond superior aircraft or weapon systems. Captain Jiro Horikoshi, chief aeronautical engineer for Mitsubishi Heavy Industries, was summoned to provide technical analysis of the reported American performance anomalies. Horikoshi had designed some of Japan's most successful fighter aircraft and possessed comprehensive understanding of the relationship between aircraft capability and pilot limitations. His initial assessment was skeptical, assuming that combat reports had exaggerated American performance due to stress and confusion during high-intensity engagements. The detailed evidence convinced Horikoshi that Americans had achieved breakthroughs in aviation medicine that Japanese research programs had never attempted. Sustained G-forces exceeding 8.5 gravities should have caused immediate unconsciousness in any human pilot, yet multiple independent sources described American aviators maintaining full tactical capability throughout such extreme acceleration stress. The implications suggested revolutionary advances in life support technology that could fundamentally alter aerial combat dynamics. Horikoshi initiated comprehensive research into physiological aspects of high-performance flight, collaborating with medical specialists from Tokyo Imperial University to understand how American pilots might have overcome natural human limitations. The investigation revealed Japan's significant disadvantage in aviation medicine research, with American programs apparently decades ahead in developing practical solutions to physiological constraints that Japanese engineers had accepted as unchangeable facts.
The research team discovered that American aviation medicine programs had been investigating G-force effects on pilot performance since the late 1930s, establishing systematic research protocols that combined medical analysis with engineering solutions. Japanese programs had focused primarily on aircraft performance improvements while largely ignoring human factors limitations that ultimately constrained operational effectiveness regardless of mechanical superiority. Flight surgeon Lieutenant Commander Yoshio Kodama, responsible for medical support of Japan's most elite fighter squadrons, documented physiological evidence of American advantages through systematic analysis of pilot debrief reports. Kodama's research revealed consistent patterns indicating that American pilots retained full consciousness and motor control during acceleration stress that rendered Japanese aviators incapacitated. The differential was too consistent and widespread to be explained by superior training or individual capability variations. Kodama's medical analysis identified specific physiological mechanisms that suggested American pilots possessed external assistance in maintaining cerebral circulation during high G maneuvers. The human cardiovascular system could not adapt sufficiently to prevent blood pooling during extreme acceleration, creating absolute performance limits that no training regimen could overcome. If Americans had developed technological methods to counteract these physiological constraints, they possessed decisive advantages in any sustained high-G combat engagement. The investigation expanded to include captured American equipment, but initial examinations revealed no obvious technological modifications that could explain observed performance advantages. American aircraft appeared mechanically similar to intelligence assessments, with no visible life support enhancements or unusual cockpit equipment that might provide physiological protection during extreme maneuvers. The breakthrough came when Lieutenant Keisuke Yamada, an intelligence specialist fluent in English, discovered references to anti-gravity equipment in captured American technical documents. The terminology was initially dismissed as translation error, but systematic analysis revealed consistent mentions of specialized flight equipment designed to counteract acceleration effects on pilot performance. The documents suggested American pilots were equipped with protective systems that enabled sustained high-G operations. Yamada's linguistic analysis identified specific technical terminology indicating American development of pressure suit technology, designed to prevent blood pooling during acceleration stress. The concept was theoretically sound but required advanced manufacturing capabilities and sophisticated control systems that Japanese industry had not developed. The discovery revealed American technological advantages in multiple fields, including precision manufacturing, automation, and physiological research. The strategic implications became clear to Japanese military leadership when they understood that American anti-G suit technology represented systematic scientific research translated into practical military advantages. If American research programs could produce technological solutions to fundamental physiological limitations, they likely possessed additional breakthrough capabilities that Japanese intelligence had not yet identified. Wing Commander Raizo Tanaka, responsible for tactical development across all Japanese fighter commands, attempted to modify existing combat doctrines to minimize exposure to American physiological advantages. Tanaka understood that if Japanese pilots could not match American high-G performance, they must develop tactics that avoided prolonged high-acceleration engagements while exploiting areas where technological advantages were less decisive. The tactical modifications proved insufficient against American pilots who could sustain offensive maneuvers indefinitely, while Japanese defenders faced physiological limitations that forced periodic disengagement. American formation leaders learned to exploit these limitations systematically, maintaining high-G pressure until Japanese pilots were forced to abandon tactical positions due to impending unconsciousness. Lieutenant Colonel Minoru Genda, Japan's most innovative tactical theorist, recognized that American anti-G suit technology had fundamentally altered the mathematics of aerial warfare. Traditional energy management calculations assumed that all pilots faced identical physiological constraints, but American technological advantages invalidated these assumptions completely. Wing Commander Raizo Tanaka, responsible for tactical development across all Japanese fighter commands, attempted to modify existing combat doctrines to minimize exposure to American physiological advantages. Tanaka understood that if Japanese pilots could not match American high-G performance, they must develop tactics that avoided prolonged high-acceleration engagements while exploiting areas where technological advantages were less decisive. The tactical modifications proved insufficient against American pilots who could sustain offensive maneuvers indefinitely, while Japanese defenders faced physiological limitations that forced periodic disengagement. Lieutenant Colonel Minoru Genda, Japan's most innovative tactical theorist, recognized that American anti-G suit technology had fundamentally altered the mathematics of aerial warfare. Traditional energy management calculations assumed that all pilots faced identical physiological constraints, but American technological advantages invalidated these assumptions completely.
Japanese tactical doctrine required complete revision to address opponents who could operate beyond normal human performance limits. Genda's analysis revealed that American advantages extended beyond individual pilot capability to formation-level tactics that were impossible without universal G-force protection. American squadrons could execute coordinated maneuvers requiring sustained high-G flight from all participants, creating tactical options that remained unavailable to Japanese formations where individual pilot limitations constrained group performance. The psychological impact on Japanese pilot training programs was immediate and severe. Instructors who had built curricula around maximizing human performance within physiological constraints discovered that their American counterparts possessed technological solutions that made traditional training approaches obsolete. Student pilots learned that their intensive preparation might prove inadequate against opponents equipped with performance-enhancing technology. Flight training commander Captain Masatake Okumiya documented declining morale among advanced pilot trainees who understood they would face technologically superior opponents in combat. The knowledge that intensive training could not bridge performance gaps created by American technology undermined confidence in traditional Japanese aviation education methods that emphasized human development over technological solutions. The investigation into American G-suit capabilities revealed broader technological disadvantages that extended throughout Japanese aviation research and development programs. American integration of medical research, engineering innovation, and manufacturing capability demonstrated systematic approaches to military technology development that Japanese programs had not coordinated effectively. Research Director Professor Hideo Noguchi, leading Japan's most advanced aviation medicine program at Osaka University, acknowledged that American achievements in physiological protection represented scientific advances that Japanese research could not quickly duplicate. The anti-G suit required understanding of human cardiovascular responses, precision manufacturing of pressure bladders, and automated control systems that responded to acceleration forces within milliseconds of detection. The anti-G suit requirements alone presented insurmountable challenges for Japanese industry operating under wartime resource constraints. Anti-G suits required specialized fabrics, precision pneumatic components, and sophisticated sensors that detected acceleration forces accurately enough to trigger protective responses. The technological synthesis represented industrial capabilities that Japanese manufacturing could not achieve with available materials and production capacity. Technical analysis of captured American flight equipment eventually revealed evidence of the anti-G suit systems that had mystified Japanese pilots for months. Hidden within apparently standard flight suits were inflatable bladders connected to pneumatic systems that automatically pressurized during high-G maneuvers. The discovery confirmed Japanese fears about American technological advantages while revealing the sophisticated engineering required to create effective physiological protection. The pneumatic control systems incorporated pressure sensors, automatic valves, and precisely calibrated bladders that applied graduated compression to prevent blood pooling without restricting pilot mobility during normal flight operations. The technology represented integration of multiple advanced engineering disciplines into unified life support systems that provided decisive tactical advantages through seemingly minor equipment modifications. Flight Test Engineer Commander Jiro Tanaka, responsible for evaluating captured American technology, determined that anti-G suit systems represented manufacturing precision and engineering sophistication that exceeded Japanese capabilities by significant margins. The automatic control systems required miniaturized sensors and rapid response valves that Japanese industry could not produce with existing manufacturing techniques and quality control standards. The broader revelation that American pilots possessed technological protection against G-induced unconsciousness forced Japanese strategic planners to reassess fundamental assumptions about aerial combat effectiveness. If American technological advantages could eliminate physiological constraints from fighter operations, numerical parity would not restore tactical balance without corresponding Japanese technological breakthroughs. Intelligence assessments revealed that American anti-G suit technology was being deployed systematically across all fighter squadrons, indicating manufacturing capacity sufficient to equip thousands of pilots with physiological protection systems. The scale of deployment suggested American industrial resources dedicated to human factors research and advanced manufacturing that Japanese programs had never attempted. The strategic bombing implications became apparent when Japanese analysts understood that American bomber escort fighters equipped with anti-G suits could sustain defensive maneuvers that would exhaust Japanese interceptors within minutes. Fighter escorts that could maintain high-G flight indefinitely provided protection levels that made strategic bombing campaigns virtually unstoppable against conventionally equipped opposition. Medical research teams led by Dr. Shibasabuki Tasato attempted to develop Japanese countermeasures against American physiological advantages through intensive study of acceleration effects on human performance. The research confirmed that no training regimen or medical intervention could enable unprotected pilots to match the sustained high-G capability provided by properly functioning anti-G suit systems. The experimental programs revealed that Japanese aviation medicine had focused on pilot selection and training, while American programs had developed technological solutions to fundamental physiological limitations. The philosophical difference reflected broader approaches to military technology development, with American programs emphasizing engineering solutions while Japanese programs relied on human adaptation and superior training. Flight testing of experimental Japanese pressure suit prototypes revealed manufacturing and design challenges that could not be overcome with available industrial resources. The precision required for effective anti-G suits exceeded Japanese manufacturing tolerances, while the automatic control systems required electronic components that Japanese industry could not produce in sufficient quantities for operational deployment. The failure of Japanese efforts to duplicate American anti-G suit technology demonstrated technological gaps that extended throughout multiple industrial sectors. Effective physiological protection required advances in material science, precision manufacturing, electronics, and automated control systems that represented coordinated research programs spanning years of intensive development. The psychological impact on Japanese fighter pilot veterans was particularly severe among aviators who had built reputations on superior performance under extreme stress conditions. The discovery that American pilots possessed technological assistance that enabled superhuman performance levels challenged fundamental concepts of pilot skill and individual capability that had formed the foundation of Japanese aviation culture. Squadron leader Saburo Sakai, Japan's most famous fighter ace, described the demoralization experienced by veteran pilots who learned that American aviators could sustain maneuvers that would cause unconsciousness or death in unprotected humans. The realization that technological advantages could overcome years of intensive training and combat experience represented a fundamental shift in the nature of aerial warfare. The strategic implications extended to post-war planning when Japanese military analysts understood that American technological capabilities in human factors research indicated broader industrial and scientific advantages that could produce additional breakthrough systems.
The anti-G suit represented evidence of systematic American investment in military technology development that Japanese programs could not match with available resources. The revelation of American anti-G suit technology marked a turning point in Japanese understanding of technological warfare, where engineering solutions could provide decisive advantages that traditional military virtues could not overcome. For fighter pilots who had relied on superior training and aggressive tactics to achieve victory against numerical odds, the encounter with technologically enhanced opponents represented a technological shock that revealed the limits of human capability against scientific advancement. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.